Good afternoon, students. So we are going to start with the class. Today we are discussing mechanical properties of fluids. Sorry, mechanical properties of solids. Okay. So here you can see the first question. See, which of the following substance has the highest elasticity? So ಯಾವ ಮಟೀರಿಯಲ್ಗೆ highest elasticity ಇರುತ್ತೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. Sponge, steel, rubber, copper. Yes. You can type your answer in the chat box. Which material is having the highest elasticity? See, the value of the Young's modulus is greater than the, this one. Elasticity will be more for the substance. Okay, so in the given metals, among the given substances, steel has the greater value of the Young's modulus. Therefore, it has the highest value of elasticity. Go for the next question. The following 4 wires of length L and radius R are made of the same material. Which of these will have the largest extension when the same tension is applied? Yes. See what they are asking here. The following 4 wires of length L and radius R are made of the same material. So 4 wires ಇದೆ, 4 wires length L ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, radius R ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, which is made up of the same material. ಅಂದ್ರೆ Young's modulus same ಇರುತ್ತೆ. Which of these will have the largest extension with when the same tension is applied? So force applied is same, material is same, length is same, and the radius is also same. So which will have the highest extension? So according to Young's modulus, the y is equal to your force, that is so here that is the Young's modulus is given by longitudinal stress upon longitudinal strain. So stress is written as what? Force by area. Here the value of that given, the Young's modulus is nothing but it is longitudinal stress upon longitudinal area, stress upon strain. Okay. So stress is given by force per unit area and the longitudinal strain is given by, that is, change in the longitudinal strain is given by, that is, change in length upon original length. So just write it as L divided by delta L. Okay. So the force upon area is nothing but tension. Here the force is nothing but tension. Area of the wire is written as what? Pi r square. L divided by delta L. Keep it as it is. So in which material delta L is highest anta kehta idare. So simplify this equation for delta L is equal to. So delta L is equal to, it will be T divided by pi r square. L divided by Y anta baritivi. Okay. That is change in the length is equal to. Yes, so in the given question, you can see that the delta L is inversely proportional to R square. The delta L is inversely proportional to the square of the radius. 1 upon R square is maximum for the wire of length. L is equal to 100 centimeter and radius is 0.2 millimeter. So meaning enanta andre, as you can see that it is inversely proportional to the square of the distance, andre distance kadme adre extension ಹೆಚ್ಚಾಗತ್ತೆ. So in the given options, which is having the least radius, that is option A is having the least radius. So therefore option A is the correct answer. So delta L is inversely proportional, therefore 0.2 square, it is option A is the correct answer. Yes. Go for the next question. Remember this type of questions many times they have asked in the exam. The next question, the ratio of hydraulic stress to the corresponding strain is known as bulk modulus, rigidity modulus, compressibility, Young's modulus. The ratio of hydraulic stress to the strain ಏನಂತ ಹೇಳ್ತೀವಿ? Yes, it is called as what? The ratio of hydraulic stress to the corresponding strain is called as. Yes, students, such a simple topic. It is a bulk modulus. Yes, it is a bulk modulus anta ಹೇಳ್ತೀವಿ. The next question is, spring is stretched by applying a load to its free end. So you have a spring, you are stretching that by applying force at the free end. The strain produced in the spring is. So again strain produce agate by applying the stress. What strain you are getting? It is volumetric, shear strain, longitudinal and shear, longitudinal only. Yes. Which type of strain you are getting by stretching the spring? Yes, it is B. That is, it is C option. That is, if we are getting both longitudinal and the shear strain. Longitudinal and the shear strain, both we are getting in that. The next question, Young's modulus is defined as the ratio. Very simple question. Young's modulus, how you define? Bulk stress upon longitudinal strain, hydraulic stress upon hydraulic strain, shearing stress upon shearing strain, tensile stress upon longitudinal strain. So it is a simple question, but only the thing is, ಏನ್ ನೀವು ಡೆಫಿನೇಷನ್ ನೋಡ್ತೀರಾ ಸ್ವಲ್ಪ ವರ್ಡ್ಸ್ ಚೇಂಜ್ ಮಾಡಿದ್ದಾರೆ ಅಷ್ಟೇ. So first you are not getting the first one, bulk stress by longitudinal strain antu barala. Second is also not there. What about the third and fourth? C or D it is. Young's modulus is defined as. Yes, it is D option. That is Young's modulus is defined as, that is tensile stress upon longitudinal strain anta ಹೇಳ್ತಾರೆ ಅಥವಾ longitudinal stress upon longitudinal strain anta ಹೇಳ್ತಾರೆ. So option D is the correct answer. C. Yes. The next question, students. Two wires A and B are stretched by the same load. If the area of cross section of A is double that of B, then the stress on B is. Yes, you have the two wires A and B. They are stretched by the same load. So you have two wires A and B are stretched by the same load. If the area of cross section of A is double that of B, then the stress on the B is. So you have two wires, same load is applied, A option. The area of cross section is A is double that of B. Area of cross section L2 object is different ಇದೆ. Then the stress on B is equal to that on A, twice that on A, half that on A, 4 times that on A. So it is B option, that is twice that on A. You can see here, that is, so see, as both wires A and B are stretched by the same load, the stress on A is given by. So stress is given by, that is force by area. Okay. Force upon area on the A body. For the B body, what they are saying, for the B body, the area is twice that of the A. Yes. So when I take the ratio of the B body to the A body, the force value will get cancelled. Then the area will be, yes. So A value will be A is getting cancelled here, and here B by A we are getting it as 2. So therefore what we can say, that the stress on the B body is equal to the twice the stress on the A body. Yes, understanding, students? A wire is stretched such that its volume remains constant. The Poisson's ratio of the material of the wire is. Yes, here the wire is stretched such that its volume remains constant. So stretch ಮಾಡ್ತಾ ಇದೀರಾ wire ಅನ್ನ, but ಅದರ volume remains same. The Poisson's ratio of the material of the wire is 0.25, 0.50, minus 0.25, minus 0.50. Yes, Poisson's ratio is given by what? It is the ratio of, that is the change in the diameter to the original diameter divided by change in the length to the original length. So here the wire, the given volume of the wire is remaining constant. So what we can do, the volume of the wire is written as what? Pi r square L. So it remains constant, and we can just take it as a K. Therefore pi r square is equal to, we have K, which implies r square into L, which implies r square into L is equal to, just write it as K dash, because the ratio of K by pi, we are just considering it as what? K dash anta ತಗೊಳ್ತಾ ಇದೀವಿ. So suppose if I differentiate this one, it becomes 2r into dr UV rule L plus r square into dl, which is equal to 0, because K dash is the constant, right? So therefore, after rearranging the terms, what we can get here, students, that is we are getting it as minus 2 dr by r is equal to dl divided by d. So therefore, dr by d is equal to dl by d is equal to nothing but what? Minus 1 by 2. So therefore, the answer is minus 0.5. That is option D is the right answer. Poisson's ratio becomes 0.5, but it is minus. While you are getting minus here, you can see the arrangement. Just hope you understood this step. What we are doing here, this is 2r dr into L plus r square dl is equal to 0. So therefore, we can just change it. R square dl is equal to, we can write it as minus 2r dr into L. Okay, so we can just make it as dl by L. ಇಲ್ಲಿ r cancel ಆಗತ್ತೆ ಒಂದು r. Okay, the remaining is dr divided by ಇಲ್ಲಿ ಉಳಿದಿರೋ r ಇಲ್ಲಿ ತಗೊಳ್ಳಿ. And here we have the minus 2. Yes. So simplification is like that. Going for the next question, students. Young's modulus of a perfect rigid body is. Yes, what is the value of the Young's modulus of the perfect rigid body is? Infinity between 0 and unity, 0 unity. So for the perfect rigid body, the Young's modulus becomes infinity. Why? Because in the perfect rigid body, strain estirutte. So strain means what? That is change in the dimensions. It is a rigid body. So change in the dimensions agala andre strain will be 0. So Young's modulus is given by stress by strain. That is stress divided by 0. Anything divided by 0 is what? It is infinity. Option A is the right answer. Solve this one. A metallic rod breaks when the strain is produced 0.2%. The Young's modulus of the material of the rod is 7 into 10 raised to 9 Newton per meter square. The area of cross section to support a load of 10 raised to 4 Newton is. Here area of cross section is given, students. Y value is given. Young's modulus is given. And the strain produced is 0.2% anta kelidare. Sorry, force is given, area they are asking. Yes. So very simple solving. Young's modulus is equal to stress by strain. So namu bekagirodu area. So area bekadre what you need to do. So when you need to calculate the area, so stress is equal to strain into Young's modulus. So strain is given as 0.2%. Hauda. So strain is 0.2% helidare. So when it is 0.2%, it is nothing but what? 0.2 divided by 100 into Young's modulus is 7 into 10 raised to 9. So if you simplify this, we will get it as 1.4 into 10 raised to 7. Now we can write stress is equal to force upon area. Okay. So we require area. Therefore, area is equal to force upon stress. So just now you have calculated the value of stress. So force is 10 raised to 4. Stress test is there at 1.4 into 10 raised to 7. So simplify, you will get it as 0.71 into 10 raised to minus 3 per meter square. But optionally minus 3 illa minus 4 al kottidare. Therefore it is 7.1 into 10 raised to minus 4. Option A is the answer C. Is any doubt in this question? Copy down. If any doubt is there, please ask. Okay, going for the next question. The ratio of tensile stress to the longitudinal strain is defined as. So this question is asked in the other form already. Howda ಅಲ್ಲಿ ಏನ್ ಕೇಳಿದ್ರು? The Young's modulus is defined as. So ಇಲ್ಲಿ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ? The ratio of tensile stress to the longitudinal strain is defined as ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Yes. So the way of question asking, you can see here how much it is difference. ಅಲ್ಲಿ modulus ಕೇಳಿದ್ರು, ಇಲ್ಲಿ ಅದ statement ಕೊಟ್ಟಿದ್ದಾರೆ. So it is option B, Young's modulus. Which of the following statement is incorrect, students? Yes, you have the 4 statements. Go through it and tell me which is a wrong statement. Young's modulus and shear modulus are relevant only for the solids. Bulk modulus is relevant for solids, liquids and gases. Metals have larger values of Young's modulus than elastomers. Alloys have larger values of Young's modulus than metals. So which statement is incorrect? D, B, yes. So it is D is the incorrect statement. That is the metals have the larger value of Young's modulus than alloys and the elastomers. ಬಾಕಿ ಎಲ್ಲ ಸರಿಯಾಗಿದೆ. ಇಲ್ಲಿ Young's modulus and the shear modulus is applicable for the solids. Bulk modulus ಮೂರಕ್ಕೂ ಬರುತ್ತೆ. ಮತ್ತೆ metals ಗೆ larger Young's modulus ಇರುತ್ತೆ. And alloys, so option D is the wrong here. For perfect rigid body, modulus of rigid in Young's modulus is infinity and bulk modulus is 0. Young's modulus is 0 and bulk modulus is infinity. Young's modulus is infinity and bulk modulus is also 0. Sorry, infinity. Young's modulus is 0 and bulk modulus is also 0. Yes, already in the one question you have seen about the Young's modulus. So here they are asking for the bulk modulus also. So with respect to Young's modulus is infinity, you have two options. Which one you will choose? A or B? Sorry, A or C? So it is C, that is for a perfectly rigid body. Young's modulus and bulk modulus both are infinity. Option C is the correct answer here, students. Okay. Next one, identical springs of steel and copper. The Young's modulus of steel is greater than the Young's modulus of the copper, are equally stretched. Less work is done on copper spring, less work is done on steel spring, equal work is done on both the springs. Data is incomplete, means what they have given the data is insufficient. Yes, which is the right answer here? It is option B, students, because work done is equal to 1 by 2 into force into delta L. So here W is directly proportional to delta L. Delta L is equal to F into L upon A into Y agatte. Here F, L, A. ಎಲ್ಲ constant ಇದೆ, okay? These are constants here. So if these are constant, then your length is inversely proportional to Young's modulus. So therefore, when it is inversely proportional, so ಅವ್ರು ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಕಾಪರ್ ಇಸ್ ಲೆಸ್ ದನ್ ಸ್ಟೀಲ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಇದು ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರೋದ್ರಿಂದ the work done for the steel is less than the work done for the copper. Next question. Let Ys and Ya represents Young's modulus of steel and aluminium. It is said that steel is more elastic than aluminium. Therefore, it follows that. So, ಯಾವ relation follow ಮಾಡತ್ತೆ? Yes, steel is more elastic than aluminium. Therefore, the Young's modulus of steel is greater than the Young's modulus of the aluminium. Option C. Yes, students, which one of the following substance has the highest value of the Young's modulus? This is steel. Already we have discussed this question. So if you want, you can note down this table, because sometimes instead of steel ಬೇರೆ ಯಾವ್ದಾದ್ರು ಕೊಟ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿರ್ಲಿ. So aluminium is 70, copper is 120 ಇದೆ, iron is 190, steel ಗೆ 200. Yes, the next question. Yes, see. If the work done in stretching a wire by 1 millimeter is 2 joule, the work done is 2 joules for the wire stretching 1 millimeter. The work necessary for stretching another wire of the same material, but with double radius of cross section and half the length by 1 millimeter is. Yes, here what they have given, accordingly you need to substitute the values in the Young's modulus formula, in the work done formula. A. So see here, that is, so stretching force is equal to, because we are using the Young's modulus formula here first. So Young's modulus is equal to what we have, students? Young's modulus is equal to, we have Young's modulus is equal to longitudinal stress upon longitudinal strain. Okay, longitudinal stress is force by area into change in length upon original length. So we are writing it for F is equal to. So F is equal to enagatte. This is delta L by delta L. So F is equal to, the formula becomes delta L by L, and here it is area. Matte Young's modulus ille uliyate. Correct. So here area is equal to, we can substitute it as what? That is pi r square into y divided by L, which is equal to force. Correct. Just a minute, I'll share it. Yes, we were discussing about this question. You see here, that is, so y is equal to t divided by pi r square, L into del divided by delta L. So delta L is equal to, it becomes t upon pi r square, L divided by y. Hagadre delta L is directly proportional to yes. So previously also we have solved this type of one question. Okay. So here we were seeing that. So now that is F is directly proportional to R square, ಮತ್ತೆ inversely proportional to L ಅಂತ ಆಗತ್ತೆ. ಹಾಗಾದ್ರೆ when I take the ratio of the forces, that becomes, so when you take the ratio of the forces, that is F dash upon F is equal to, so this is 2R, ಯಾಕಂದ್ರೆ twice ಹೇಳ್ತಾ ಇದ್ದಾರೆ, and it is the length is reduced to half for the F dash, ಮತ್ತೆ F ಗೆ length is L and the radius is R square. So with respect to this, if you simplify, you will get L cancel ಆಗುತ್ತೆ, R square cancel ಆಗುತ್ತೆ. So it is 2 square is 4, 4 divided by, ಇದ್ ಮೇಲ್ ಹೋದ್ರೆ multiplied by 2, that is 8. So F dash by F is equal to, it is 8, therefore F dash is equal to 8F. So now the work done in stretching that wire is given by, work done is equal to 1 by 2 into force into delta L. So keep 1 by 2 as it is, the force is 8F into delta L, right? So now this is just a ratio of both, that is 8 joules into 2 joules, because the first work done is 2 joule anta kottidare. So the answer is 16 joules, students. Yes, copy down. Okay. Is the next question. 4 identical hollow cylindrical columns support a big structure of mass m. The inner and outer radii of a column are R1 and R2 respectively. Assuming the load distribution to be uniform, the compression strain of each column is. So copy down the question. I'll tell. Yes, students completed. So here the area of cross section for the air column is given by, it is having the inner radius R1 and the outer radius R2. So therefore area is equal to pi into bracket R2 square minus R1 square. Since each column supports 1/4 of the load, therefore F is equal to mg by 4 anta agate. So the compressional strain of each column is given by force upon area into Young's modulus. So force is mg by 4. ಮತ್ತೆ y ಅದೇ ರೀತಿಯಾಗಿ ಇಡಿ area is pi into r2 square minus r1 square. So remember the compressional strain is given by F divided by A into y. Yes. Yes, this is a formula actually. The elastic energy stored per unit volume in a stretched wire is. So here we do the derivation also for this formula. The elastic energy stored per unit volume in a stretched wire is. Just see here. The stored energy per unit volume in a stretched wire is given by U is equal to 1 by 2 stress into strain. Yes. So the strain can be written as stress divided by Y. So therefore stress into stress becomes stress square divided by 2 into Y. Therefore option B is the correct answer. Understood this one? How to do it, Anta? See here, that is they are asking the energy stored is given by 1 by 2 into stress into strain. Okay, so which is equal to 1 by 2, keep it as it is. Stress also keep it as it is. Strain, what you are going to do? Strain you are going to write it as what? So illide nodi. Strain is equal to, strain ill hodre y ill baratte. Hoda strain is equal to, it becomes stress upon y. So stress into stress is nothing but it is stress square divided by 2y. Option B is the correct answer. It's the next question. Two wires of the same material and length, but the diameters are in the ratio 1:2, are stretched by the same load. So load applied is same and the diameter is are in the ratio of 1:2. The ratio of the elastic potential energy per unit volume of the wire is. So ಈಗಷ್ಟೇ ನೀವು formula note down ಮಾಡ್ಕೊಂಡಿದ್ರೆ you can understand this question. So same material ಇದೆ, length ಇದೆ, but the diameter ಅಷ್ಟೇ it is 1:2 ratio ದಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. Force is also same. The ratio of the elastic potential energy per unit volume. Yes, see here students. The elastic potential energy, just we have seen, it is 1 by 2 into stress square upon y. So it is directly proportional to stress square anta agate. Hagadre U1 is equal to stress square. So stress is nothing but force by area. That is F1 by A1 and whole divided by F2 by A2. So just take the reciprocal. Rearrange the terms. So area is written as pi r square. The ratio pi will get cancelled. So when the ratio pi will get cancelled, you have only radius. So here the radius is taken as d2. Yes, it is 16 by 1. Option D. The next question. Young's modulus of a wire depends on. Yes, on which factor the Young's modulus of a wire depends? Diameter, mass, length, material. It is D. The Young's modulus depends on the material of the wire. You go for this question. In the, okay, leave this, take this one. A wire of length. So the wire length is given as L and the radius is R is clamped at one end. So one kade adana fix madidare. On stretching the other end of the wire with a force F, the increase in its length is L. So increase in the length estaagta ide, it is becoming L. If another wire of the same material but of length 2L and radius 2R is stretched with a force of 2F, the increase in its length will be. So whatever the force is there, the force they are making it as 2F. The length they are making it as 2L and the radius is becoming 2R. The increase in its length will be. Yes. So you can see here, students, the Young's modulus is equal to longitudinal stress by longitudinal strain. So by arranging the terms, we will get it as FL divided by pi R square into L. It becomes FL divided by pi R square into L. Plus the extension produced on the second wire is L dash. ಹಾಗಾದ್ರೆ ಫಾರ್ಮುಲಾ ಏನಾಗತ್ತೆ, ಆವಾಗ ಫೋರ್ಸ್ 2F ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ and the radius is becoming, it is pi into bracket twice divided by L dash divided by 2L. Yes. So therefore here whatever the terms are there, if I equate this equation 1 and 2, so this is your equation 1, this is your equation 2. If I equate equation 1 and 2, FL will get cancelled, pi R square will get cancelled. So what you are getting? You are getting it as what? L dash is equal to L. Correct? So therefore option C is the correct answer. So in the option C, they have given the increase in the level will be L itself. It's the last question. See how to do this one. Again, one more we will do. So see this. The radii and Young's modulus of the two uniform wires A and B are in the ratio 2:1 and 1:2. So the radii matte Young's moduli of two uniform wires, it is 2:1. Radii ratio 2:1 matte Young's modulus ratio 1:2. Both wires are subjected to the same longitudinal force. So ಎರಡಕ್ಕೂ same force apply ಮಾಡ್ತಾ ಇದೀವಿ. If the increase in length of the wire A is 1%, the percentage increase in length of the wire B is. Yes, copy down this. So you ಮತ್ತೇನಿಲ್ಲ, just formula ತಗೊಳ್ಳಿ, ಫಾರ್ಮುಲಾದಲ್ಲಿ radii ಮತ್ತೆ Young's modulus ratios ಅನ್ನ substitute ಮಾಡಿ just ratio ತೆಗೆದ್ರೆ ನಿಮಗೆ ಆನ್ಸರ್ ಗೊತ್ತಾಗುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ. So see, Young's modulus is equal to FL upon pi R square into delta L. Therefore, delta L by L is equal to F upon pi R square into Y. Okay. So now for the second wire, the change in the length is delta LB by LB strain. ಮತ್ತೆ first wire ಗೆ delta LA by LA which is equal to. So take the ratios of the radius because baki terms ಎಲ್ಲ constant ಇದೆ cancel ಆಗತ್ತೆ ಅಲ್ಲಿ. So radius square ಮತ್ತೆ Young's modulus. So question ಅಲ್ಲಿ radius ratio 2:1 ಅಂತ ಮತ್ತೆ Young's modulus 1:2 ಅಂತ ಇದೆ. So if you simplify you will get it as 2. Okay. So now LB by LB, delta LB by LB is equal to 2 into delta LA by LA. They are asking in terms of percentage. So multiplied by 100 on both the side. Therefore, it becomes 2%. Option C is the correct answer. C. Yes, copied on. We will see one more question. Yes, students, please do it and tell me the answer. A steel cable with a radius 2 centimeter. R value is given. Chairlift at a sky area. If the maximum stress is not to exceed 10⁸ Newton per meter square. So stress is given, radius is given, the maximum load the cable can support is. F value you have to calculate, force. Please check how much you are getting the answer, tell me. B. Yes, it is B. Radius is 2 centimeters. So it becomes 2 into 10⁻² meter. Maximum load is equal to maximum stress into area of cross section. So stress is 10⁸ into area is pi r square. So keep pi as it is. R is 2 into 10⁻² square. So it becomes 4 pi into 10⁻² plus 4 Newton. So this is the answer. That is option B is the correct answer. C. Hope so you understood how to do this one. So stress is equal to force by area agatte. Namagu bekagirodu force. So force is equal to stress into area. That's it. Yes, students. So this is regarding the mechanical properties of solids. Hope it is clear to you. So very simple lesson. So please practice few more questions so that you can attempt all the questions in this chapter in your exam. Okay. So we will meet tomorrow. Thank you. Good day.